Okay, this is the first of two demonstrations involving what is called the ripple tank. The ripple tank is this tank of water, and then down in my sink below here I have a light bulb, which is then casting the reflection up here up onto the screen. Okay, now I'm going to go ahead and tap the water like so, and then when I do, think of my finger here as a point source of circular water waves, which then propagate outwards from that point, and they propagate in 2 dimensions on the surface of the water. The amplitude of the wave decreases very rapidly as the wave propagates, and the reason for that is not necessarily due to damping, but instead the energy associated with the water wave is spreading out over an increasingly larger and larger surface area. So if I tap the water like so, I then produce these circular waves in this manner. Okay, now here's a quick demonstration of Huygens principle. What I have right here is a board with a bunch of nails that are nailed into it, and then each one of these individual nails is going to be a point source of circular wavelets, as Huygens originally coined the phrase and referred to them as. And then these individual circular wavelets then encounter one another, and when they do, they interfere, and that then produces more or less a straight line here. If you can look along the tank, for example, as the wave propagates, you will see that the waves look more and more like a straight line, like so, and this can then be used to produce then what is referred to as a plane wave. Huygens principle will become very important later on when talking about light. Okay, now let me also demonstrate refraction here as well. I'm going to do so by changing a portion of the depth of the tank. I'll do so by placing my glass like so here into the tank. Let me go ahead and get rid of some of the bubbles, air bubbles associated with it, like so. Okay, and then in the short clip in the Mechanical Universe episode on waves, one of the things that I illustrated is that the speed of a water wave depends upon its depth. The greater the depth, the greater the speed. So in deep portions of the tank, this then means that the wave is going to be fairly fast. In other more shallower portions of the tank, where the glass is, for example, this then means that the waves are going to slow down. What you will see is a noticeable bending, if you will, in the direction of the propagation of the waves as they pass over the glass. Like so, that's right over here in this area. Watch for it again. Like so. You can see that the waves here are noticeably bent, that is, they are refracting as they slow down when passing from deep water where there is no glass to shallow water where there is glass. Like so. Okay, that's the first of 2 demonstrations involving the physical ripple tank. I'll go ahead and set up a part 2 in just a few moments.